In item 6 on the second exam, note that we have a three-span continuous beam with a uniformly distributed load, and we're provided the qualitative shear diagram. And someone has proposed a moment diagram to go along with this, and we're asked to come up with the correct and incorrect aspects of this proposed moment diagram. Right, so from a correct standpoint, there's a couple of big things and a couple of little tiny nitpicky things that you could say are correct. For instance, a nitpicky thing, still important, is that the moment at the ends equals 0, and that's as it should be. We have pin and roller support there at the extremities, so that's correct. You could also say the general trend of the moment diagram is correct, that we have increasing and decreasing moment where we should, right? And so we have positive shear here, the moment is increasing, we cross over to negative shear and the moment is beginning to decrease. Likewise, and that happens in all three segments, so that's a good thing as well. And then you could also say, hey, when the shear is hitting 0, that's usually an indication of at least a local maxima or minima on the moment diagram. And so the peaks of the moment diagram correspond with the 0 shear. That's good. We would also expect that when we have the sudden change in the shear diagram, we should have a sudden change in the slope of the moment diagram. So that's also, you could say, as a fourth thing, that at the interior reactions, shear changes sign, and so does the slope of the moment diagram. And it not only changes, but it changes in an appropriate manner. So those are all good points. I was hoping that you would get at least 4 of those, or 3 of those. The moments at the end are, yes, they're important. They are sort of in a sense, they're sort of given, but that is kind of correct. And if you didn't have that, well, that would be a big minus. There's no doubt about that. But perhaps the 3 ones that I saw immediately were these others. But and you could really be nibbling around the edges here with the moment at the ends. I was hoping you'd get at least those 3 things. The overall trend is kind of important. The peaks being pretty close to where the moment is 0. Right? Now, so those are some of the good features. The negative features of this are that the moment diagram should be second order, right? And that's because we have a load that's constant, and then we integrate the load to get shear, and that gives us first order, and we integrate then the shear, and we get second order, right? And that's not the case. Instead, first order is shown, and that's everywhere. So that automatically makes this incorrect, although it does follow the general pattern that we expect to see, but that makes it incorrect. And that's the primary thing that is incorrect here. Now you could begin to try to really nitpick things here, and you could argue, for instance, that gee, wherever you have 0 shear, that's where exactly the moment should peak out, and that's off a little bit in the drawing. They haven't been very careful about where the reaction effect is at in either the shear or the bending moment diagram. So you could nitpick those things if you care to, and again in this last segment it appears to be really far off. Likewise here where the peaks are at, You see there's something off. So that is true, that's incorrect. In some sort of, if in a really narrow, detailed kind of fashion, you could point out something like that. You could also begin to quibble about the nature of how much change in moment should have happened across that span. It almost looks like you have similar triangles in each one of these, and if so, that might suggest that we have a net zero change in moment all the way across that span, and that's not what's indicated on this moment diagram. Well, that's starting to get into some esoterics that we can't really address. It's highly argumentative because we don't have numbers. This was a qualitative shear diagram, and so because of that, we can't know for sure that's the case. Yeah, it might suggest that, but we don't know that. And so it's not really quite true to say that if the shear diagram was correct, that therefore we'd have a moment diagram that was nothing but on the positive side. And in fact, actually the moment diagram that is shown here is far closer to the overall absolute values of the internal bending moments in the span that is supporting load, as we've got shown here. Then it's closer to being correct than it is to being wrong. The big major thing that's wrong with this is that we should have second order curves that might look something of this kind of nature, and we'd have to know something more about the details of the loads and the span lengths, and even the moment of inertia and elastic modulus for each of these three spans before we know what the relative magnitudes of the peaks of the moments are, peaks both positive and negative peaks. Now, the other thing that some people have pointed out and wanted to talk about was, gee, shouldn't there be zero slope where we have the shear being zero? And they want to say that somehow this is correct, but really we have an undefined slope right at those points, right? We have a definite slope to the left and to the right, but right at that point we can't really say what we know that slope is. It's undefined because of the discontinuous nature there. So that would not be a correct aspect of things here. If anything, you could argue that that's another symptom of not having the right order of the curve through here, is that the slope really should be changing in a continuous fashion instead of an abrupt fashion. And of course it changes exactly in a second order fashion, or actually the slope itself changes in a linear fashion as we go across, that is.